Hello viewers on YouTube. In this video tutorial, we are going to understand how to find the identity and the inverse element of a particular binary operation. So first and foremost, it is important to understand what the identity of a particular binary operation means. So the identity given a non-empty set S, which is closed under binary operation. If there exists an element E, there is an element E, which is this, whereby E is an element of that given set, non-empty set. And it is observed that when a particular element in set S, which is A, is combined with that E, and again, if this turns out to be equals to that E being combined with that element, and at the end of the day, the result is equal to that element, then E is said to be the identity element or the neutral element of set S. Similarly, for the inverse element, given a non-empty set S which is closed under a binary operation at stake, if X is an element of S, which is a particular element in S, and there exists an element X prime such that when X is combined with X prime, the result is the same as X prime being combined with X, and at the end of the day, the results provides the identity E, then X prime is called the inverse of X in S. Now you need to understand that both identity element and inverse element are unique in any operation. They are usually one value. Okay, they don't vary. Okay, as long as it is on a particular operation, then they remain unchanged. Perfect. Now to understand this more better, let's try to go over some examples. Example number 1. The operation asterisk on the set of rational numbers Q is defined by A asterisk B equals A plus B minus 1 for all A comma B is an element of R. Find the identity and inverse element in Q under the operation asterisk. So to find the identity first, we need to understand that A asterisk E, where A is an element of rational numbers, must be equals to E asterisk A, and it must be equal to A. So whatever answer we have is our identity. Now, since the operation is defined by this simply means that A asterisk E is equals to A plus E minus 1, and this will be equals to A as the element. Now let's focus more on these terms. So therefore, A plus E minus 1 will be equals to A, and if we take this one to the side, likewise the A, we can clearly say that the identity E is equal to A minus A plus 1. When this becomes minus, and at the end of the day, we can clearly say that the identity E is equal to 1. So for this operation at stake, the identity E, which is inside the rational number, is equal to 1. Now what about the inverse? We know that the inverse is such that when we combine that inverse, let's assume it is A prime, when we combine it with A, then the result must be A combined with A prime, and at the end of the day, it must provide A. So let's just work with this equals to this. So therefore, A prime, which is unknown, we are trying to look for, asterisk A must be equal to E. Now from the definition of that equation, anything being combined together gives us their sum, that's A prime plus A minus 1 equals to E. However, we've got E earlier to be equals to 1. Therefore, A prime plus A minus 1 equals to 1. And when this one is taken to this side, we have A prime plus A equals to 1 plus 1, and A prime plus A equals to 2. And taking this A to this side as well, we have the inverse element to be equal to 2 minus A. And that is the solution to this problem. And that's how to find the identity and inverse element of a particular binary operation. On to example number 2. The operation asterisk on the set of rational number R is defined by A asterisk B equals A B over 3 for all A comma B is an element of the real number R. Find the identity and inverse element in R under the operation at stake. Now we know that A combined with the identity E is the same as the identity E combined with the element A, and this result back in A. Since the operation is defined by this simply means that A asterisk E is equal to AE over 3. Now since A asterisk E is equal to A, then definitely AE over 3 is equal to A. And from cross multiplication, we have AE equals to 3A, and dividing through by A, eventually A results in 3, or E results in 3. So therefore, the identity element of this problem is simply 3. Now about the inverse, we know that if there exists inverse A prime, if we combine it with an element A, this is the same as the element A combined with inverse A prime, and this at the end of the day results in E. So A prime is what we are looking for. Let's combine it with A. At the end of the day, it must be equal to A. Now the operation is defined by this. So this simply means that A prime asterisk A is simply A prime times A all divided by 3. E is equal to 3. Since these two terms are equal, and therefore A prime A over 3 is equal to 3, which is the identity. Perfect. Now from cross multiplication, A prime A is equal to 9. And dividing through by A, keep in mind this is 9, not 8. We have A prime to be equal to 9 over A. And that is our final answer to this problem. So the identity is 3, and the inverse is 9 over 8. Perfect. On to example number 3. The binary operation asterisk on the set of real numbers R is defined by x asterisk y equals to 2x plus 2y minus 1 all divided by 2. For all x, y is an element of real numbers. Find the identity and inverse element in R under asterisk. Feel free to pause the video and use what you have learned so far to solve this problem. So let's begin. Just like before, we know that to determine the identity, then if we combine x with the identity E, this is the same as the E being combined with x, and at the end of the day, the result provides x. So since the operation is defined by this simply means that x asterisk E gives us 2x plus 2e minus 1 all divided by 2. Now, since we said above that the result will be equal to x, then we can set it to be equal to x. So this simply means that 2x plus 2e minus 1 all divided by 2 is equal to x. From cross multiplication, we can clearly see that 2x plus 2e minus 1 is equal to 2x. And if we subtract 2x from both sides, we can clearly see that 2x minus 1 or 2e minus 1 equals to 2x minus 2x. And simplifying this forward, we can clearly have 2e minus 1 to be equal to 0. Adding 1 to both sides, we have 2e equals to 1. And dividing through by 2, we have e equals to 1 half. And that is the identity element of this problem. So what about the inverse? Now, from our knowledge, the inverse, we know that if the inverse exists, or let me use x this time around, the inverse x prime combined with x, that gives us x combined with x prime. And at the end of the day, the result provides the identity. So, since the operation is defined as this simply means x prime combined with x is simply 2x prime plus 2x minus 1 all divided by 2. Now, since the result is equal to e, and e is equal to 1 half, so therefore we can set this to be equal to this. And therefore we have 2x, this is 2x, okay, does not have power, 2x plus prime, okay, plus 2x minus 1 all divided by 2 equals to 1 half. Now from cross multiplication, we can have 2 times 2x prime plus 2x minus 1 equals to 2. Now notice that the 2 can cancel, and we can have 2x prime plus 2x minus 1 equals to 1. Now the goal is to solve for x prime. We are out of space, so let's get rid of some stops. So therefore, 2x prime plus 2x minus 1 equals to 1. So when we add 1 to both sides, we have 2x prime plus 2x equals to 2. Dividing all through by 2, we have x prime plus x equals to 1. And eventually, if we subtract x from both sides, x prime equals 1 minus x. And this is the inverse of the inverse element in R under the operation at stake. And that's how to easily find the identity and inverse element of any given binary operation. Before we end the video, let's consider one last example. On to example number 4. The operation at stake on the set of real numbers R is defined by A at stake B equals to AB over 4 plus A plus B. For all A, P is an element of R. Find the identity and the inverse. So I will recommend you pause the video and figure this question out yourself. So let's begin. Now, just like before, we know that when we take an element in the real number and then combine it with the identity, if you don't know what it is yet, this is the same as the identity combined with that element. And at the end of the day, the result will be that particular element A. So A combined with E, according to the definition of this operation, is simply equals to AE over 4 plus A plus E. That just replacing accordingly or respectively. Now, since the result will be equal to A, then we can set these and these to be equal. So therefore, AE over 4 plus A plus E is simply equals to A. Now, at this point, the two A's can cancel. When this A comes to this side, it becomes negative A and it cancels this. Perfect. So therefore, we have AE over 4 plus E equals to 0. So right now, we can multiply all 2 by 4. So multiplying all 2 by 4, we have AE plus 4E to be equals to 0. And factoring out E, we have A plus 4 left over to be equals to 0. And dividing all through by A plus 4, we'll observe that our identity E is simply equals to 0 over A plus 4, which is indeed equals to 0. And that is the identity element. So what about the inverse? Let's determine the inverse as well. So for the inverse, to have that, let's have enough space. So let's get rid of this. Don't forget, E is equal to 0. Now we notice that the inverse is such that if it exists, A prime, if we combine it with a particular element A, that is the same as combining that same element with its inverse, and the result is simply E. Now from the binary operation, the inverse combined with a particular element A is simply A inverse times A divided by 4, then plus A inverse plus A. We have used this. Perfect. So the result is equal to E, then we can set these to be equal to this. But don't forget, E is equal to 0. So therefore, A prime times A over 4 plus A prime plus A is equal to 0, which is the value of the identity. So right now, I can bring this A to the side. Now we have A prime times A over 4 plus A prime equals to negative A. Since A is common, we can factor out A. And we have, since A prime is common, we can factor out A prime. And we have A prime multiplied by A over 4 plus 1 to be equals to A, negative A. So now dividing all through by A over 4 plus 1. Then we have A prime equals negative A divided by A over 4 plus 1. And that is our final answer. So by now, I want to believe that you are now able to find the identity and inverse element of a given binary equation. Thanks for watching. See you in the next video. So this is your exercise. Feel free to share your solution via the comment section below. So consider finding the identity and inverse element of the two operations for both x and y and p and q. Thank you once again. Bye for now.